Hello, everybody, and welcome to the Astro Show, a place to be if you're curious about the cosmos. I'm your host, Dr. Sam, the founder and executive director of Wyoming Stargazing. Here, you can pick the brains of astrophysicists, get advice from a space doctor, learn about what scientists have to say about life, and find out what's going on up above your head, all in the same place. So we hope you'll join us twice a month on the second and fourth Tuesdays at 6 p.m. Mountain Time. You can watch our live stream on Facebook, Twitch, and YouTube. On Twitch and YouTube, you can chat your questions, or you can actually call in through our stream through Zoom with the information that you have on your screen. And we would love to hear from you. So don't be afraid, call in, ask some questions, make some comments, join the conversation. On this week's show, we're going to be chatting with Dr. Krista Smith, Assistant Professor of Physics at Southern Methodist University. Among other things, Dr. Smith studies accretion disks around supermassive black holes. And just coincidentally, we just got our second picture of a supermassive black hole just a couple of weeks ago. So we are very excited to have Dr. Smith on later in the show. But before she joins us, let's welcome our co-stars. First, doctoral graduate in astrophysics from the University of Chicago and host of her very own YouTube show, Nora's Guide to the Galaxy. It's Dr. Nora Bailey.
Hey, y'all.
Hey, Nora. Next, clinical supervisor for student teachers at Western Governors University. It's Dr. Michelle Valdez. And next, founder of the Space Tourism Guide, it's Valerie Stymick.
Hello.
Hey, Valerie. Unfortunately, Dr. Nick and Dr. Danny can't join us tonight, but they will be back.
And Dr. Lauren.
And Dr. Lauren, who I forgot about that. Yeah, I hadn't updated my notes. Thank you, Nora. And Dr. Lauren Corley's also can't join us tonight. She is feeling under the weather. That was a more recent update. Thanks. I appreciate that, Nora.
I've just got to say, I need to get myself these letters after my name.
You
There are
do.
so many doctors.
You do, Valerie.
Overwhelmed.
Highly recommend.
Yeah, we've been joking with Nora about that. She just got hers what, 2 weeks ago, something like that.
Yeah, about a month ago.
About a month
Got the
ago.
letters.
Yeah. So, yeah, we got lots of FUDs in the room, which is great. All right, well, let's get going with Astro Advice, life advice from astronomers, astronauts, and other scientists. So the quotation that we have for tonight is this: "Nothing in life is to be feared. It is only to be understood. Now is the time to understand more so we may fear less." And we have 4 possibilities of who our quoter might be for tonight. A is Marie Curie, Nobel laureate in physics and chemistry. B, Neil deGrasse Tyson, a notable American astronomer. If you don't know who Neil deGrasse Tyson is, well, you haven't been paying attention. Jocelyn Bell Burnell, discoverer of the pulsar. I should say Dame, Dr. Jocelyn Bell Burnell. She does have some honorifics. Also a winner of the Breakthrough Prize in Physics back in, maybe that was 2015, 2016, something like that. And of course, 4th option, Dr. Jill Tarter, the co-founder of SETI. Co-stars, I'll give you a moment to think this over, and then you can cast your vote for who you think the correct quoter of this great idea about fearlessness is.
I have no idea, but how do I cast my vote?
Oh, you just, whenever you're ready, you just say it.
Oh, I just say it. Oh, okay.
It's just, we keep things simple here, low tech.
Okay.
Hey, we got Michelle back. All right. And she's gone again. All right, Valerie, it sounds like you were ready to cast a vote.
Well, I'll cast a vote, but this is a wild stab in the dark. I'm just taking a guess because I think sometimes you have to do that, and it's not Who Wants to Be a Millionaire, so there's not very high stakes. I'm going to go with Dame Dr. Bell Burnell.
Okay, very good. We will put Valerie down for the Dame Dr. Jocelyn Bell Burnell. Nora, what do you think?
I have no idea. And I think every time we do this, we end up having like as many different possible answers, which just goes to show that apparently, I don't know, maybe us astronomers all think somewhat similarly, at least in what we think other astronomers might have said. I'm gonna go with Neil deGrasse Tyson.
Okay. All right. So Nora is going for Neil.
Okay, here we go.
All right, we got Michelle back. You are just in time to cast your vote for who
Okay.
you think actually said this quotation. And your options are Marie Curie, Neil deGrasse Tyson, Jocelyn Bell Burnell, and Jill Tarter.
Okay, so I got frozen for a while, so I don't know the quotation.
Okay. Oh no, I'll say it again. That's all good.
Okay.
The quotation is, "Nothing in life is to be feared. It is only to be understood. Now is the time to understand more, so we may fear less."
And then can I have the list of?
Yeah. So option A is Marie Curie,
Mhm.
Nobel laureate in physics and chemistry. B is Neil deGrasse Tyson, American astronomer. C is Dame Dr. Jocelyn Bell Burnell, discoverer of the pulsar. And D, Dr. Jill Tarter, co-founder of SETI.
So we just cast our votes.
Yeah, what do you think?
I think A.
A, for Marie Curie. That's what Michelle is going for. And the correct answer is, next slide, please.
Marie Curie, maybe.
Marie Curie. Nice work, Michelle. You get 1 point.
I'm just
for
so
that
worried
correct-
about this.
You got it. Nicely done. So I was doing a little research on Marie Curie this afternoon. Absolutely amazing person. First woman to win the Nobel Prize. Also, I believe the second woman to win the Nobel Prize.
Oh, wow.
She first shared the Nobel Prize in physics with her husband and with another physicist for his work on discovering radiation. And then about a decade later, she won a second Nobel Prize in chemistry for that same work on isolating radium and radioactivity. And went head to head with the University of Paris to get a decent lab. She threatened to resign and leave the university. And that's what got her the full lab that she wanted. So pretty awesome to do that back in the early 1900s for anybody, let alone a woman at that time in the sciences. So yeah, she was quite a trailblazer. And yeah, really pushed the envelope forward in our understanding of radioactivity. She helped to develop a portable X-ray machine to be used during World War I for medical outposts, which is pretty amazing. So yeah, really, really amazing work in the sciences and for equality and women in the sciences. All right. Any thoughts about this quotation? It's kind of interesting. Valerie and Michelle, you don't know this, but the last show we actually had another quote about fear. This one takes a slightly different position on it. So I'm curious what the three of you think about what Marie Curie had to say about fear.
Can you read it one more time?
Yeah. Nothing in life is to be feared. It is only to be understood. Now is the time to understand more, so we may fear less.
I'm just thinking that word understand. It shows up several times in that understanding, you know, kind of what you're facing. If you kind of realize what it is, maybe your brain can process a little more, just like, you know, fear is a big thing, but I think when you start to understand why you fear something or why you feel something. That word just stood out to me.
Yeah. Likewise.
I admire the sentiment that nothing in life is to be feared. I don't personally have that strength and fortitude. I will only say this because when I was out observing the lunar eclipse earlier this month, I was in the dark, obviously, and heard a crazy possum noise and was instantly afraid. So I admire anyone who aspires or does live by the idea that nothing in life is to be feared. It's only to be understood, because I am still afraid of horrifying possum noises in the dark.
Yeah, I really like this idea, and I think there's a lot of truth to the point that a lot of things that we fear are because we don't understand them. And so I think we can cut down on fear with understanding, but I don't think that every fear is that way. I think I've mentioned this before on the show, but I am horribly afraid of spiders. And this was, something when I was a kid, my parents tried to, teach me all these facts about spiders so you won't be afraid of them. And it just doesn't work like that. I'm still terrified of spiders.
Right.
I don't care. I know that I'm 6'4" and they're like an inch tall, and it doesn't matter. They will terrify me. So, there's only so much you can do, but I think it's a good effort. And also, I feel so morbid. I feel like I'm always like being really morbid when we talk about these. Where's Nick to back me up? but like, one of the first thoughts I had when you revealed that this was Marie Curie, I was like, well, her research killed her. So, maybe that was something to be afraid of, because she didn't understand that was something that could happen. And very unfortunate that she died at a relatively young age because of that. So, we want to understand things as much as possible to cut down on our fear, but these things are not always completely 1-to-1 ratio.
Yeah, that irony did not escape me. So I guess the issue with that is, when does understanding actually lead to the right amount of non-fear? And maybe we should fear things that we don't totally understand before we completely understand them. But yeah, she unfortunately did find out the hard way.
It's a balance. And I mean, she sacrificed to give us a lot of knowledge. So that was
totally.
Yeah.
Any other thoughts on this one?
I did just want to make a quick plug. One of the other options for this question was Dr. Jill Tarter, who was actually a guest on the show last year, and that was a really fun show. So if you're curious, you should check that out. It should be on the Wyoming Stargazing channel. I believe it was July last year. So
yeah, that was a great show too. It was a pleasure to have her on the Astro Show, then known as the Cosmo Show. Thanks for that, Nora. All right, well, let's move on to Astro 365, this day in astrophysics history. So on this day in 1930, the name Pluto was selected for the recently discovered, now dwarf planet, then planet. And if you do a search for where that name came from, you get a couple different things. Some suggest that Clyde Tombaugh actually came up with the name, who was the discoverer of Pluto at Percival Lowell Observatory. But if you do a little bit more digging, you find out that Percival Lowell Observatory, where the discovery was made, actually opened up a competition for people to come up with a good name for the planet at the time. And they received over 1,000 entries. And the entry that was eventually selected was from an 11-year-old girl in England by the name of Venetia Burney. And if you do some research on her, you find out that she didn't actually submit her entry into the contest herself. Her grandfather actually did on her behalf. Her grandfather was a teacher and was just telling her about the discovery of this new planet. And apparently the story goes is that she had this idea that it should be named as the other planets were by Greek mythology. And she came up with the name Pluto because Pluto is the god of the underworld, supposedly very cold and very distant from the sun. And then the story goes that Percival Lowell really liked that entry, not because of the name Pluto, but because of the letters PL, which also stood for Percival Lowell, the observatory at which he made his discovery. The truth is clouded in history. We don't really know whether Venetia Burney was the only person to come up with this name. We don't totally know if it was actually her or her grandfather, but this is a story that is circulating in the annals of astronomical history right now. And I'm curious if Valerie, if you've dug up anything to the contrary, since you do this kind of work.
I have not. I actually was just looking, I was on Wikipedia looking her up, and she's fascinating, not only because she is credited, we'll say, whether or not she actually came up with the name naming Pluto, but she also has an asteroid named after her. And one of the instruments on New Horizons was named after her. So she had a strong legacy, even if there were contributors to the overall naming process.
Yeah, and a crater on Pluto.
Oh, yeah. Yeah.
Indeed. And I mean, she's just a darling little girl in that 11-year-old picture of her, right? But yeah, I thought that was kind of a cool thing to have happened on this day in 1930.
What sounds the most interesting to me is how people submitted their entries. Like, it obviously wasn't electronic. It wasn't on a website. It was like sending a letter, sending a postcard,
Telegraph,
and to travel, all the way from England by mail, assuming it was by mail, had to go on a plane. It was a long journey for her entry to make it in the entry window to be selected. It's kind of interesting to think about that.
Yeah. Yeah, and interestingly enough, so she only heard about the discovery on March 14th from her grandfather. And then the name was finally selected only 6 weeks later on May 1st. So yeah, very interesting time frame there. And now, poor Pluto, poor planet, but it's got lots of friends out there, so it's all good.
And this started the trend now that all trans-Neptunian objects tend to get names associated with the underworld, which I think is cool.
It is cool. Yeah, not necessarily from Greek mythology, but in Hawaiian mythology. I guess that's what Mike Brown is partial to, and he's made a lot of the discoveries. So we have a lot of Hawaiian gods and goddesses out there.
Well, he uses the telescopes on Hawaii, so I think that's a good homage.
It is indeed. It is indeed. And yeah, who knows if Planet 9 will actually be named in a similar way if it turns out to actually exist. Any bets on that before we move on?
Do you think it exists?
Mm-hmm.
Do you?
Oh, me personally? Yeah, I think it's there.
Yeah.
Yeah.
I saw the most
skeptical.
fascinating planetarium show at the Adler. There we go. Got the word out. The Adler about Planet 9, and I was blown away. It was one of those rare times. It was probably very early in my more professional approach to being involved in the space industry, and I just was like, the science. It seems so obvious. We just have to find it, and it's like, well, you have to have enough light to find things in the dark, and just because the science says it's there doesn't mean we can see it with the tools we have, which I think is really cool little puzzle for people to solve.
It is.
I think it's debatable if the science says it's there or not.
Okay. Well, from the planetarium show,
I have seen
was
that planetarium show at the Adler, and they do a great job there. But
it's very convincing.
This is still a very active area of research, I would say, and it's just unfortunately relying on very small numbers of objects. So trying to make statistical inferences from very small number of populations is difficult, and the search for the planet hasn't been the most successful. So, but we'll see.
Yeah, I think the James Webb has a shot. The
Yeah.
problem is we don't really know where to point it.
I think the best thing, as far as it's not necessarily discovering it, but like that it actually exists, will be the Rubin. So just they'll get a larger sample size that will really, I think, settle the question once and for all of whether there is a statistical bias in the.
And where's James Webb right now?
It's at the Lagrange point. Yeah, the L2 point, about 1 million miles away.
Wow.
Yeah. I mean, and they've given us first light from all of their tests, and I think we get the first research images within a couple weeks, right?
Sometime in June,
Yeah,
I think is kind of the goal, but
yeah,
we'll see.
Yeah, it's pretty exciting. All right. Well, for the rest of Astro 365, we are going to do our news quiz. 3 questions per co-star, and we're going to start with Nora, our reigning champion.
Bring it.
All right. So far, Michelle
She's a
has
smart one.
Michelle has 1 point. Both Valerie and Nora have no points. But here we go, Nora, for 3 points. Here we go. Question 1. A new computer simulation suggests that the gravity of this planet may have flung dwarf planet Ceres into the asteroid belt during its formation.
I'm just gonna go with Jupiter.
You got it. All right, 1 point.
He likes to throw his weight around.
Okay, number 2. Which NASA spacecraft just got delayed yesterday, at least a month from its scheduled launch date to explore an object of its namesake in the main asteroid belt?
I actually know this one, and I know I said I wasn't going to know any because I've been on vacation, but I was on Twitter today and I saw this, and it's Psyche.
Yeah! All right, number 2. Nora takes the lead.
Unfortunately.
Yeah, Nora takes the lead. All right, 3rd question. An article published earlier this month in the Journal of Astrobiology claims that the famous wow signal might actually come from which type of star?
I think I saw a headline about this, but I don't know. I don't think the headline said. Pulsar?
Way simpler than that. I'll give you one more guess. Way more normal.
Way more normal than a pulsar, but still is going to have a weird signal.
Nope, no weird. I mean,
no weird signal.
I mean, weird signal, but not a weird star.
Just give a color, maybe.
Oh my gosh, I don't know.
Even simpler than that.
Oh, really?
Like a binary star?
Nope, sorry, I can't give you that one. It's a sun-like star.
Oh, but wait, what? Okay, I need to go find this paper.
Yep. I think it was the May 6th issue of Journal of Astrobiology.
Interesting. All right.
Yeah, sun-like star.
Mechanism
they did a search of Gaia data of the area of the sky where the wow signal was obtained from, and this is how I don't remember the method they used to narrow it down.
So they're like narrowing it down to a sun-like star. Yeah. I see. Interesting.
I know, very interesting. All right, so Nora, you got 2 points there, and you have the lead. All right, Valerie, you are up next. Are you ready?
Come on, Valerie.
All right, here we go. You got this. Okay, confirmed yesterday by President Biden, which country's astronauts will be joining NASA astronauts on the Artemis mission to the moon?
I have not been on Twitter enough recently. This is my bad.
It's okay.
I'm just gonna go wild and say Japan.
You got it. Yeah. All right. 1 point for Valerie. All right. Number 2. What aerospace company's spacecraft Starliner recently docked with the ISS for the first time?
I know this because I listen to a lot of airplane podcasts also, so it's Boeing.
You got it. All right. Valerie is now tied with Nora for 2 points. For the lead, Valerie, recent findings from Peter Van Dukum's research team at Yale University shed light on the possible origins of 2 dwarf galaxies, DF2 and DF4. Unlike other known galaxies, these two to be Unlike other known galaxies, these two appear to be devoid of what?
Okay, I'm gonna just take a wild guess, and I'm gonna say planet/exoplanets.
Oh, so close, but not this time. So the correct answer was dark matter. They're devoid of dark matter. So you are tied with Nora for 2 points. So we're potentially going to have a three-way tie for first place here, or Michelle is going to crush it and get all 3 correct answers and be our new reigning champion. Michelle, are you ready?
Okay.
All right, here we go.
Pluto.
No,
Just kidding.
wait. The United Nations Postal Administration released a set of what this week commemorating human achievement on Mars?
Say it one more time.
Yep, it's as easy as it sounds. The United Nations Postal Administration released a set of stamps. You got one.
I was getting so nervous.
Yeah, I told you, don't have to think into this too far. Okay, number 2. The Event Horizon Telescope just released a long anticipated photo of what object last week?
The moon.
Not the moon.
That. I can do this. Along of a star.
Nope,
Oh.
this was the supermassive black hole in the center of the galaxy, Sagittarius
Of course,
A.
I just had that up the whole time.
Okay, for the tie, for a three-way tie. Actually, no, you already have 2 points. So this is still for the win if you get this last one.
Okay.
And this one's not a trick question. I'm just saying it in a fun way. Faster than a speeding bullet, more powerful than a locomotive. What's flying past Earth later this week?
An asteroid.
Yeah, you got it for the win.
Are you kidding me? I can't even believe it. I was so stressed about this point.
You got it. And not only any asteroid, this sucker is over a mile long, moving at about 45,000 miles an hour, 5 times faster than a speeding bullet. But it's 10 times farther away than the moon. So we do not have to worry about this. But yeah, a large asteroid, near Earth object, we would have given you that as well. So you are our new reigning champion, Michelle. Nice work.
I can't believe I beat Nora and Valerie, like the smartest ones here.
Fair and square.
Fair and square.
I will say I did a reel today about this asteroid. This is a really cool asteroid. And I learned finally that there are not just Jupiter asteroids, there are Apollo asteroids, and Apollo asteroids are the ones that cross Earth's path or orbit, and that they're like the ones we have to really care about. I had never heard of that term before I started researching this one.
Yeah, these aren't the Trojans.
Trojan, thank you.
Yeah.
There's a lot of words for asteroids. It gets very confusing.
It does indeed. Almost as many names for trans-Neptunian objects.
Yep.
All right, so we've got one more new segment that we are putting in the show, which we've never done before, which I'm really excited about. And this is where we're going to just share something cool that is happening up in the sky. So we're calling it "What's Up, Dr. Sam?" It's just that simple. So what I picked out for you this week is actually pretty cool. There might be a new meteor shower coming up next week. And this might not be just like your stereotypical meteor trickle that we get month to month throughout the year. This might be one of the best meteor showers in the last 100 years. Or it might be a complete dud. We don't know. But on May 30th, on Monday, May 30th, at about 11 o'clock p.m. Mountain Time, which is like perfect time for this time of year for Wyoming. It doesn't even get dark until like 10:30. So right after it gets dark on Monday, May 30th, Wyomingites, go outside. And you don't have to go far in Wyoming, but if you're in a more brightly lit city, get out to a dark place. And these meteors may actually be coming from almost directly overhead, from like 80 degrees up. So 90 degrees is straight above your head. So 80 degrees, just a little bit off from the zenith. There could just be a few of them. There could be thousands of meteors this night, but we just don't know. If we go to the next slide, I'll show you the comet that fragmented back in 1995 and has been fragmenting ever since. We now think into over 60 different pieces. And so if the particles from this fragmented comet have moved away in space in just the right way, we're going to be flying through this debris field of comet fragments on May 30th. And it could be an amazing, amazing show. Potentially even better than the Leonid meteor shower of 2002, which was like the creme de la creme. I think there were in some places over like 600 to 1,000 meteors an hour there. It was pretty phenomenal. I remember watching it in college. This one could be even better. So yeah, hopefully the weather forecast holds out. Right now, it's actually looking pretty good in Jackson, Wyoming on May 30th. So don't miss your opportunity to see a pretty awesome meteor shower. If you go to the next slide, I just got a picture of where the radiant is. So this is the part of the sky from different points on Earth where the meteors will appear to be coming from. So you can see there's that green dot up in like Baja, California. So in Baja, California, they'll be emanating from directly overhead. And as you move radially outwards from Baja, they appear to come from different parts of the sky. So Wyoming is around like 80 degrees. And then as you get farther away from Baja, the meteors appear from closer and closer down from the horizon. But basically anywhere in the United States, you got a chance to see it. A lot of places on the west coast of South America. It could be really, really cool, or it could be nothing. But even if it's nothing in Wyoming, there's still lots of cool stuff to see up above your head. So get out there on Monday, May 30th at about 11 p.m. and check things out. It should be pretty cool. And that's it for What's Up, Dr. Sam tonight. So we're going to take a quick break, and we will be right back with our special guest, Dr. Krista Smith. So stick around, and we'll see you in a few minutes. Don't go. Welcome back, everybody. We are here with Dr. Krista Smith, Assistant Professor in Physics at Southern Methodist University. Dr. Smith, thanks so much for being here.
Of course. Yeah, I'm really excited to be here. Thanks for having me.
Oh, yeah, we're psyched to have you. Just like we always do, we're going to start off the guest spot with the same question, which is, what's the one question that you wish everyone would ask you, but nobody ever does?
Okay, so after I learned that this is what you ask your guests, which was a while back, I have been thinking about this a lot. And I woke up this morning still unable to think of one. But what I decided I wanted to say here in response to that is a large part of my job is being asked questions. And in lots of capacities. I mean, obviously I'm a professor, so I get the student questions. I work on black holes, and I think I've heard every question about black holes I ever want to hear. For the people next to you on the airplane, people, in class, people just randomly at the store. But also I'm on a lot of committees for different NASA missions, review committees and renewal committees for these missions. The Astro Decadal Survey, early career panel. So what are the priorities for missions and stuff coming up in the future? And then a lot of equity and inclusion panels where I'm asked really important questions about the state of the field. So all I could think of when I was thinking about your question were questions that I get asked all the time. And so, so what I would really like the most, instead of someone asking me a new question, would be for people to listen to the answers.
Nice. That's a great twist. I like that.
You spend a lot of time thinking about these questions, and sometimes they are asked of you just as sort of a checkbox on a to-do list of the administration or something like that. And once they've gotten your report that you spend a lot of time thinking about, you and your peers and people who are invested groups, it just kind of goes in a drawer, and the next year they make a new committee and they ask the same questions again. So that would be my answer. Is I fortunately I get asked questions often and a lot, and I really like answering them. But I would really love it if people would listen to the answers, including my students, who could listen better to the answers sometimes.
If you're watching out there, students of Dr. Smith, there you have it. Well, that's a great answer. That is very different than all the others we've received so far. So I appreciate it.
I tried.
That was good. That's good. So tell us a little bit about how you got into the field of astronomy.
Yeah, so this is sort of in general, it's the usual answer. I was a little tiny kid and I always wanted to be an astronomer, but I remember what the kind of actual moment, which is that I remember I used to like this pattern in the stars. I know now that it's the top half of Orion, but at the time I thought it was just two eyes. And then what I saw was the belt, but it was three stars in a diagonal. And I thought it was kind of like a crooked face, like the emoji with the tilt, although we didn't have emojis then. And I liked it, and I started kind of paying attention to it. I must have been 4 or 5. And I used to look for it all the time. And then we made this big trip to Colorado, which is the farthest I had ever been away from home. And I saw it there and I was amazed. I was like, how can the same thing, everything else is different, right? There's mountains. I grew up in Dallas, no mountains. There's mountains here, there's trees, but there's not this, but this pattern is somehow the same. And I was like, wow, this is crazy cool. And then some time passed and I couldn't find it. And I was, it was springtime, I guess, and I could not find this thing at all. And so I went to the library and I stood on my tiptoes and asked the librarian the question, and she didn't know the answer, but she took me to the little astronomy part of the library, which I could barely read because I guess it was 5 or 6. But I started opening books and looking at the pictures. I didn't get my answer for several more years, but anyway, after that, and that also not only cemented me as an astronomer, but an observational astronomer, not a theorist. Been making observations all along. I'm also a big Trekkie, so that probably
nice. Likewise. That's a great story. Very cool. I don't remember the first time I saw Orion. Do any of the other co-stars have an early memory of a constellation? Oh, Michelle.
Yes, Orion. I love Orion, that winter star. I'm just looking at this is Snow King right here in Jackson. But in the winter, that'll come up. And I remember being really young and I just wanted to know those 2 bright stars, the orange one and the blue one. And I learned their names really early, Betelgeuse, and I thought Betelgeuse, that's a cool name for Orion as a little kid, and then Rigel later. But I still look at that star all the time. Just think when I was young, just looking at that. But in Wyoming, it's just there. It's
Yeah.
like you said, Dr. Smith, it's like in your face in this part of the world. It's just gorgeous.
Yeah. So Dr. Smith, so you had this inspiration as a kid, and I mean, was that it? You went right into astronomy as an undergrad and all the way through to get your
Yes,
PhD?
I started studying astronomy on my own as soon as I could. I really dorkily would take notes on paper during Astronomy Night on the Science Channel, which was Tuesday nights. And so my family knew that I was going to sit in the living room and watch this documentary on comets and take notes on it. And they just weren't going to get to watch TV. I mean, this was before you could stream or had lots of TVs, right? So, so I started learning it as early as I could. I only applied to colleges that had an astronomy degree. And yeah, I just from the very beginning, I didn't ever want to do anything else.
That's super cool.
The older I get, the more I realize how much of a blessing that is. I mean, I have many sisters. I have 7 sisters, and you know, many of them took a long time, or still trying to figure out, you know, what they want to do, what direction they want to go. And there's a range of ages there, but you know, the more I see, the more nice it is, you know, to know exactly what you want, or early enough to vector towards that right from the beginning. It's really nice.
Yeah, I share that blessing. I knew I wanted to do stuff with the night sky from a very young age as well. So consider myself lucky there also. So what about black holes? How did you end up studying black holes?
Yeah, so this is less fated, I guess. Is that so it took me a little while to find the school that I would stay at. So I first went to Embry-Riddle in Northern Arizona, which I really liked because they had a degree called space physics, which sounded super cool. I don't know how that school has changed, but when I went there, it was 87% male. And it was mostly like an Army school. And I, for many reasons, did not fit in very well in that environment at all. I shouldn't say Army, it was an Air Force, like ROTC Air Force school. Sorry if anybody's watching from Embry-Riddle. It was a great, you know, the classes were great, my classmates were good, but it wasn't the place for me. So I transferred quickly to UT, University of Texas at Dallas, because my family was in Dallas and I didn't know what I wanted to do, but I knew I didn't want to pay private school tuition anymore. So I quickly went to UT Dallas and lived with my parents again for a year, and then transferred to University of Texas at Austin, which is where I did my undergrad. But because I kind of bopped around at different universities, and UT Dallas didn't have astronomy at that time, it does now. But I did not know about undergraduate research. I didn't know how to get into it. I wasn't part of these freshman research initiatives or anything. So I started kind of hearing that you were supposed to do this. Now, every applicant to our grad program has a first author paper. But I mean, at that time, this was 2009, I didn't know how to do this. And so I looked on the website and I looked for research opportunities in our department. And there was a little table, and it said the name of the professor, the subject, and the required skills. And I had no skills. And so I scrolled through the table and looked for the lines that had empty boxes in the required skills column, because a lot of the boxes would say like proficient in IDL, blah, blah, blah. And I had none of that. You know, I came from a rural, you know, small school here in Texas. We didn't have computer science in high school. And so I just picked the first one I saw there, which was active galactic nuclei, which is an accreting supermassive black hole at the center of a galaxy. And that's what happened. I started working with that professor. I really liked it. I got to go to observatories, and you know, that's like a almost religious experience for me. And so yeah, so I just adored the subject. I mean, I did try other things. I did do a brief project on exoplanet theory, so dynamics, like theoretical orbits of exoplanet systems. Well, I didn't love it. And I've done some other kind of like exoplanet. I do like exoplanets generally, but mostly I use the telescopes that are supposed to find exoplanets, TESS and Kepler, to study what's in the picture there, the accretion disk around a supermassive black hole.
Yeah, we noticed that and we thought that was totally cool. So I would love to personally hear more about that. And by the way, Nora is our exoplanet expert here. So.
And I am a theoretical dynamicist.
Oh, you're a dynamicist. Okay.
We're a weird bunch. I don't take that.
It was the Upsilon Andromedae system, which at that time was thought to have a cross, like 2 exoplanets.
Yeah, they're the high mutual inclinations.
Yeah. Yeah.
Fascinating.
Yeah. So I remember the project, but I'm an observer through and through.
That's fair. I couldn't touch a telescope. It would not go well.
Yeah, so you wanted to hear more about the Kepler and TESS stuff. Yeah,
and how you're using that for an unintended purpose of those telescopes, which I think is super cool.
Yeah, so the point of Kepler and TESS was to find exoplanets using the transit method. And what that means is that you watch, Kepler did something a little bit different than TESS in the way that it monitored things, but in general, you watch a large population of stars and you watch how their brightness changes with time. And if a planet passes in front of a star, it briefly blocks some fraction of the light of the star. It causes a dip. If you're plotting the brightness over time, it stays constant. When the planet passes in front of it, the brightness goes down, and then it returns back up to the flat level once the planet gets out of the way. And so that's called the transit method. And it turns out that in order to see the signal, which is extremely faint, extremely, like it's like, fractions of a percent, small fractions of a percent of the light of the star is blocked during these events. So you have to design an incredible photometer. And a photometer is something that counts photons, and TESS and Kepler were the most sophisticated optical photometers ever built. And in addition, you don't ever want to look away, because if you look away, then you possibly miss the transit, which can only last a couple of days in some cases. So you never look away. You always keep watching, keep taking the measurements every half hour in the case of Kepler, and now every 10 minutes, or actually 2 minutes now in the case of TESS. And so you never look away. And also, if you want to be sure of what you saw, you have to see multiple orbits. So you look for a long time. And it turns out that those 3 things, that you never look away, you look for a long time, and you have extremely high photometric precision, are also ideal for studying fluctuations in the brightness of accretion disks. And it's just very, it's not what they were meant to do. A lot of software development was required by me, and so other people tried, but the other people weren't graduate students, and I had no choice but to figure it out, because that was my thesis. So I developed the software to use the Kepler data, Kepler was first, and TESS is what's operating now. Kepler operated from 2009 to 2013, and then again from 2014 to 2018 as K2. But it's done now. It has served us well. But yeah, it so happens that the behavior of material as it falls into the supermassive black hole, it's magnetic, it's turbulent, there's lots of flares and kind of different timescales of interest, and we really struggle from the ground to understand the physics, because we miss huge chunks of time for weather, for daytime, for seasons, and we don't have the precision that we need. And so dealing with these light curves is the name for a plot of brightness over time, gives us an incredible new insight into the physics of matter as it's falling into the very distorted space-time around the black hole.
That is so cool.
Yeah, it is.
So you might have been a little bit excited a couple weeks ago when we got the picture of Sagittarius A.
Yeah, so I mean, we got the M87 image a few years ago, and at that time they had told us, there's two black holes that have the angular size on the sky that we can actually use the Event Horizon Telescope to see them. And that was M87. It's not very close by. It is sort of close compared to some other galaxies, but it's enormous. And Sagittarius A star, which is small, but very, very close. And so we've been waiting for 4 years for the image of Sagittarius A star. Every time someone gives another talk on the Event Horizon Telescope results, everybody asks the same question, and they don't even have to ask it anymore. People just raises their hand, and the speaker's like, "Oh, you're going to ask me about Sagittarius star." I finished kind of going, I went through the papers this past week, in some detail, and really tried to understand the physics there, what we're seeing. And it's great that we can do this. I was definitely excited. We have unbelievable evidence before this that black holes existed. There was almost nothing else that could describe the observations. And in fact, AGN, or active galactic nuclei, like the one in the image, are one of the first, open and shut evidence that it had to be a black hole at the center of the galaxy. There's nothing else that could describe the kind of suite of observations that had been made in the 1960s. But of course, there's nothing like seeing it, the actual black hole itself. So if people have not been convinced yet, there's really no place left to hide for these alternate ideas. It is a black hole.
Yeah, I was excited about all that as well. I was hoping you could tell us a little bit more about the image that we've got up there, and how it relates to what your research is about.
Yeah, sure. So I love this picture. I saw this like 3 or 4 years ago. It's my favorite artist rendition of what we call the central engine. So we think that all galaxies have a central supermassive black hole. We know the Milky Way does. We just got a photo of it. But all galaxies have this giant black hole at the center that has millions to billions of times the mass of the sun. And in most cases, 90% of the time, that black hole is just minding its own business. It's not accreting. Our black hole, the image that we got recently of Sag A star kind of shows that the accretion rate, the rate of material falling into the hole, is extremely low. Just stellar wind material from the nucleus basically just falling in. But in about 10% of cases, something has happened, like a galaxy merger, to drive material into the center. And in that case, that material comes in with some initial angular momentum. It gets captured by the gravity of the hole, and it forms an accretion disk. And that's what you see in the center of the image. The kind of flat circle going outward from the hole is the accretion disk. And that's material that's swirling into the hole like water down a bathtub drain. But that material, unlike water, has a strong magnetic field. It's ultra ionized plasma. It's extremely hot and tenuous, and it kind of, the magnetic fields twist, and there's a lot of turbulent eddies, and there's a whole lot of very interesting particle and high energy astrophysics going on in the disk. We also know that the black hole, which is spinning, also gets spun up a little bit by this material that's falling into it, and there's a mechanism in place that allows a jet, which is the ray that's being launched out of the corner of the image there, to be launched from the material that is accreting onto the black hole. And the source of that energy, it's sort of extracting the spin energy of the black hole to launch the jet. So you can imagine that the black hole has, or there's magnetic field lines coming up in kind of a cone, but if you twist it, then the magnetic field lines form a sort of a funnel. And so you have this kind of ionized, this cannon to launch ionized plasma away from the inner accretion disk. And then surrounding the whole thing, the whole engine, is this puffy cloud donut looking thing. And that's what we call the dusty torus. So around the accretion disk is this torus structure that's very patchy and full of dense dust clouds that are sort of as close as they can get to the hole, because they stop at the sublimation radius. So at some point, dust gets sublimed by the energy from the nucleus. And the reason I love this image is because each of the pieces I just described to you emits primarily in a different part of the spectrum. So the torus emits in the infrared, the disk emits in the optical and ultraviolet, and the jet emits in the radio and gamma rays. And there's also an entity called the corona that's close to the base of the jet that emits in X-rays. And so in order to understand this whole anatomy, we have to use all of the telescopes that we've built. So radio arrays from the ground, infrared telescopes on airplanes or on mountains, optical telescopes in space or on the ground, X-ray telescopes on the space station or in orbit, and gamma ray telescopes in orbit. So it's sort of a complicated beast. But if you're looking at all at the same time and watching how all those things change together, you can start to understand the causal properties and the things that are happening here.
Thank you so much for that amazing explanation. That was incredible. I'll ask one more question and then I'll shut up and let any of the the co-stars ask some questions as well. But I'm curious about what you think the time frame might be where we can actually take an image like this, a composite image, obviously, from all those different types of telescopes. So it'll be, not a true image, but a composite image actually showing all this detail around a real black hole, if ever.
It'll be a very long time. So the radio, we're getting close. I mean, we have the EHT images. The radio, we can see very small scales because the wavelengths are very long. So we can use interferometry which is having lots of different dishes networked together to mimic a large telescope. There are infrared interferometers. Gravity in all capital letters is an important one that's kind of off the ground now. But the shorter wavelengths you go, the more it is almost prohibitive to do interferometry. And so in order to be able to get this resolution, our X-ray and gamma ray telescopes now have miserable resolution compared to optical and radio. That's just, the photons are so energetic that the way we have to focus them doesn't let us get the position as precisely as we can for the other images. We're working on it, but it'll be decades, conservatively.
I'll wait around. Do any of the co-stars have any questions for Dr. Smith?
I guess I just have kind of a general question about AGNs.
Okay.
I'm just thinking back to some of my earlier astronomy courses, because obviously this is something I deal with on a regular basis. But this idea that, lots of different objects that we have observed are really just AGNs from different angles. I thought that was kind of the accepted paradigm, but I'm not sure if it is, I guess. So I'm curious if really everything that we say is an AGN actually is an AGN, or is there actually different objects, I guess, at play?
And that's a really good question. The image that you're seeing there is sort of the classic picture, and the way we're looking at it shows us the accretion disk, and it shows us kind of the inner regions. And for a long time, that was sort of one type of AGN where you could see signatures in the optical spectrum that looked like the nuclear region. And then if you were looking at it edge on, you would be looking through that dust thing. And the dusty torus blocks your view of the central regions. And so what you're talking about is the unified model, which was the proposal that these weird looking spectra that look different in these types of objects were actually the same object, but sometimes you could see the nuclear region and sometimes you couldn't. And then there's a third type where that jet is actually pointed directly at you. And that's what we call a blazar. And in that case, the emission from the jet completely overwhelms the emission from the accretion disk and the clouds nearby, and you see a very different kind of spectrum. But through population statistics and other kinds of observations, we've pretty well determined that the unified model is quite good. For example, in objects that look like just the dusty torus, where you can't see the central regions, if you then look in polarized light, you do see the same spectrum as in the nucleus. Or if you look in infrared light that can make it through the dust, you see the same spectrum as in the nucleus. However, there is a lot of consternation about the unified model. Some people think that some objects don't have a normal accretion disk, or that the torus is not that kind of donut, but is in fact kind of just patchy clouds that you can sometimes see through. So there is diversity. There's the unified model does not capture all AGN. And there's a lot of people working on the exceptions, especially when you get to very low accretion rates, there can be some subtleties. So the unified model is good, but it does not capture every type of accreting supermassive black hole.
Cool, thanks.
Sure.
I'm going to ask a question that makes me feel a little bit dumb, but I have to ask it because I'm looking at the image and I'm wondering if anyone else feels the same, since probably most people's conception in their minds of a black hole is what they saw in Interstellar.
Yeah.
This is a rendition that shows the accretion disk as two-dimensional, more or less, like it looks flat, like a pancake.
Yeah.
Is it flat like a pancake, or is it less pancakey in an actual, like, do we know? Is it
yeah,
3D or 2D?
We do know. And so if you have a nice healthy accretion rate where you have like water in a bathtub drain falling into the hole is a sphere, I mean, spherical-ish, which is a three-dimensional object, and the disk is thin. So the standard model is called the thin disk model. It's optically thick and geometrically thin. So it's not a pancake quite. There's a meridian in the disk that has, a denser core, and then there's kind of an atmosphere or corona above and below the disk of more tenuous gas. And then the accretion primarily happens in the midplane of the disk, while the top part has kind of these cool instabilities and wavelets that can get blown kind of away from the disk. So it is quite flat in that scenario. However, if your accretion rate starts to go down, then you have less dense gas, which can't effectively cool itself. So the disk poofs into this kind of donut structure that barely can accrete because it becomes this kind of round, low density sort of thing. The interstellar disk is the flat disk. It's just bent around, the photons from that disk are lensed around the hole in such a way that you get kind of that thing in the middle that looks like Saturn, and then the photon orbits around the outer ring. But yeah, in the standard picture, which of course there's 1,000 papers saying the standard picture is wrong. In the standard picture, it's a thin disk.
Thank you.
Michelle, any questions or comments for Dr. Smith?
So I've been like losing internet connectivity, so I'm like just like off and on. Let's see. So about black holes, I was like observational, like you, like looked to the sky, it was little, but about black holes, as you're a kid, you're gonna get sucked into everything. I love what you're talking about. Like you just think that, and I love that whole it's like a system within a system. It's like you're talking about like, the universe is a system. So black hole appears to me to be in a system.
Yeah, it is. I mean, that touches a little bit on the other thing I work on, which is not the accretion disk itself, but the effect that the engine has on the galaxy that it's in. Because it has a profound effect on the evolution of the host galaxy, despite being quite small compared to the host galaxy. I mean, the whole engine is about, like, the accretion disk, you can think of it to be about the size to the orbit of Pluto. And not always, it depends on the size of the mass of the black hole, of course, but you can think of it as the size of a solar system in the middle of a galaxy, quite small. But the energy that's put out by this system, it completely changes the evolution of its host galaxy. Just the whole galaxy suffers lack of star formation, feedback, turbulence, gas evacuation.
Interesting.
All kinds of things. So it is a system that speaks both directions, from the galaxy to the whole and from the whole back to the galaxy.
I feel like we need to have you back for a whole nother show to talk about all that.
I know. I was like,
Yeah, everyone likes the accretion disk stuff, but the feedback stuff is kind of the bread and butter. It's easier to understand.
Can I ask one quick question to follow up on what you just said? So you said that the engine is producing energy out into the system, the galaxy, but then you kind of use negative terms like the galaxy suffers and its whole formation is like, how could it be positively putting out energy but causing a negative effect?
It does two things. It either pushes the cold gas completely out of the galaxy by entraining it into the outflow, or it heats the gas in the galaxy from a radiative standpoint from the center, or kinetic energy. Either way will heat the cold gas. And so if you do that, then you have destroyed the fuel that is used to form stars. Stars only form from cold gas, and if your gas is either not there or hot, then it won't form. And so it is believed, it bears out in simulations, that AGN are effectively killing the star formation in the host galaxy, turning it off and making the blue star forming galaxy transition into what we call a red and dead galaxy. Now there's other things that can do that. It's much more complicated than I've just made it sound. But in general, it's called negative feedback, that idea that the AGN can evacuate or heat the gas beyond a star forming threshold.
So that it seems to suggest that there are going to be a lot of galaxies that are red and dead at some point in the distant future.
Yeah, for a lot of reasons. I mean, even if you don't have your AGN ever turn on, which it probably will, because most galaxies go through a merger at some point, which drives the gas to the center, eventually you will run out of gas to form stars with. And so you'll just have a red galaxy because all the young blue stars die. They live very short lives compared to the long-lived red stars. So eventually, yeah, it'll be a pretty red universe.
wow.
Red's a nice color.
Yeah, it's fine.
Well, we're about out of time, Dr. Smith, but I just wanted to see if there are any final words of wisdom you want to leave us with, or anybody out there, including your students who might be watching, or future students.
Yeah, I mean, I think what's important is to think about everything's kind of interconnected, everything, the things. One thing I really want to get across, that we barely touched on, the fact that I use lots of different wavelengths and lots of different skills and things like that to do this, but every field of astronomy that you're interested in is connected with a different one. And so like things that I learned in my planetary science class have been useful in what I'm doing with accretion disk physics, thinking about light curves, thinking about how sunspots and astroseismology change light curves and how to use that information to work with these data from telescopes that study stellar fluctuations instead of accretion disk physics, and not just software, but Kepler almost died in 2013. That was in the middle of my thesis. And at that time, I panicked because I thought I was going to have a thesis, and my advisor panicked as well and found me a radio astronomy project. One of our grad students had recently quit to become a baker, and she had left behind a funded project by the NRAO to look at outflows in AGN and AGN feedback, which is the star formation phenomenon I was just discussing. So I did that for a year, learned how to reduce radio data, which I thought was a huge waste of time. And now it turns out that that's this kind of intersection of these jets, which we see in the radio, which I know how to analyze because of that. This feedback and the accretion disk physics driving the engine is all connected, and it's making it a lot easier to understand the big picture. So I would say, try a lot of things, but don't think anything is a waste of time.
Nice. I love that. I love how the twists of fate can lead us down certain paths and prepare us for things that we least expected.
Yeah, make the best of it. All knowledge is worth having.
Indeed. Yeah, and to tie that back to our quotation
Yes.
for this evening, Marie Curie's idea of understanding to alleviate fear.
Definitely. Yeah.
Okay,
And
so-
that's the thing about black holes. That's a big thing that I tell a lot of people, is that black holes don't suck. They actually don't suck. You fall into one the way you fall into any hole. And if you maintain a respectful distance, you won't be falling in. And so they're, you know, they're not to be feared. They're like bears, just stay far away.
Indeed, and carry bear spray, black hole spray.
Yeah,
No, the analogy falls apart there. All right, well, Dr. Smith, it has been a pleasure. Thank you so much for being here. And I wasn't joking about having you back to go into more depth about this stuff.
Anytime, yeah, I had an awesome time. This is really cool what y'all are doing, and I'm really happy to have been a part of it.
Yeah, well, thank you so much. We really appreciate it. And we've got a thank you gift for you. Our operations director, Maggie, will follow up with you about that. Yeah, and yes, thank you again for being here. Thanks to all of our co-stars, especially Valerie and Michelle, who came in on short notice tonight to fill in. We really appreciate both of you so much. Thank you. And as always, thanks to Nora for being here as well. For the folks behind the scene, Gavin, our stream master, Maggie, our operations director, and everybody else who makes the Astro Show possible, the Wyoming Stargazing Board of Directors, and all of you at home watching. We really appreciate you being here, and we wouldn't be here without you. So thanks so much, and we hope to see you again in a couple weeks. Until then, be well, and don't forget to look up. We'll see you next time. Bye.